Good morning, one and all. In this session, we'll discuss about the intensive and extensive properties. Intensive properties are obtained from extensive properties. That is, so intensive properties are dependent on extensive properties. What are extensive properties? Like mass, volume, all this. So density. Intensive properties, examples of intensive properties are density or internal energy. So for example, if we want to calculate the intensive property, example density, we need to have mass and volume. That is because density is the ratio between mass and volume. U is the internal energy to mass. So intensive properties of matter are color, order, luster, melting and boiling point, specific heat capacity, malleability, ductility, conductivity, density and pressure. So intensive properties do not depend on the amount, whereas the extensive property depends upon the amount. So state function, a property of a system that depends only on the state of the system. Path function, a property of system that depends on the path by which the system achieved a particular state. So state function only depends upon the current state of the system. How the system attained the state does not matter here. It means a state function depends upon what is the present position of the system, and it does not matters how it has reached that state. Example of this state function is a compression of a gas in a piston. So a state function is defined as a property of a system that only depends on the initial and final state of the system and is independent of the path followed for achieving that particular state. Importance of dimensions and the units. Any physical quantity can be characterized by dimensions. So the magnitudes assigned to these dimensions are called units. Some basic dimensions such as mass, length, time, temperature are selected as primary or fundamental dimensions, while others such as velocity, energy, volume are expressed in terms of primary dimensions, are called as secondary dimensions or derived dimensions. So mostly SI unit or SI system mass is used to unit as the dimensions. Any physical quantity can be characterized by dimensions. Magnitudes assigned to these are called units. So for example, the length of the particular thing is measured in meter, mass is measured in kilograms, time is measured in seconds, temperature is measured in Kelvin, electric current amperes, light in candela, matter in moles. So other one is specific volume, that is specific volume of a matter with respect to the time. Similarly, the specific volume of substance is the ratio of the substance's volume to its mass. The molar mass is the volume occupied by 1 mole of substance at a given temperature and pressure. Force. According to Newton's second law of motion, the force acting on a body is directly proportional to the time rate of change of momentum. For a body of constant mass, Newton's law reduces to F is equal to CMA, that is directly as a force is directly proportional to the mass and change in momentum, that is momentum is again in proportion to mass and the acceleration of the body. So F is equal to CMA, that is mass of the body and the acceleration of the body. In the SI units, F is equal to MA as C is equal to 1. If mass is measured in kgs and acceleration is measured in meters per second square, the units of the force is called kg meter per second square, and this kg meter per second square is as a whole is called a Newton. So these are some of the problems. Next one is density and specific gravity. Density is the ratio of the mass to volume, that is the units of the density will be kg per meter cube. whereas the specific gravity is the ratio of a density of a substance to the density of a some standard substance at a particular temperature. As both it is a ratio of the density, the specific gravity is a unitless, whereas the specific volume, similarly the specific volume is volume of a particular substance to the volume at a particular of a reference substance. Hence this specific volume is a unitless. Similarly, the specific volume specific weight is the weight of a unit volume of a substance. So here the specific gravities of some of the components are like every component has its separate its own specific gravity values. Next one is pressure. What is pressure? It is the ratio between the internal force and the area of the surface that is in contact, that is F by A. As F is calculated, that is if we consider at a particular distance, so F into distance, that is work, area into distance is called volume. This means pressure is equal to energy by volume, that is joules per meter cube. Next one is pressure. So absolute pressure, the absolute pressure at a given position, it is measured relative to absolute vacuum. Gauge pressure, the difference between the absolute pressure and the local atmospheric pressure. Most pressure measuring devices are calibrated to 0 in the atmosphere, and so they can indicate the gauge pressures. So this is the vacuum pressures, that is pressures below the atmospheric pressures. Variation of a pressure with depth. As the depth varies, the pressure also varies. So the pressure of a fluid at rest increases with the depth as a result of because of the add-on weight on it. So similarly, if we measure the pressure of any particular object which is in a liquid at rest, so the pressure in a liquid at rest increases linearly with the distance from the free surface. Similarly, in a room filled with gas, the variation of pressure with height is negligible. The pressure is same at all the points on a horizontal plane at a given fluid regardless of geometry, provided that the points are interconnected by same fluid. The manometer is the device used to measure small and moderate pressures. Manometer contains one or more fluids such as water, mercury, alcohol or oil. So this is how a manometer measures the pressure. Means the pressure at a particular point plus density and gravitational force plus A plus H. So the pressure at a second point is equal to the pressure of the atmospheric pressure plus P1. Next one is temperature. A temperature is an objective comparative measure of a hot or cold. It is measured by thermometer. Several scales and units exist for measuring the temperature. The most commonly used are Celsius, Fahrenheit and Kelvin. The coldest theoretic temperature is absolute zero, at which thermal motion of atoms and molecules reaches its minimum. Classically, this would be a state of motionless. Absolute zero is denoted by 0K on Kelvin scale. If we consider it a degree Celsius, it is minus 273.15 degrees on the Celsius scale. Temperature scales. All temperature scales are based on some easily reproducible states such as the freezing and boiling points of water. The ice point, that is ice point and steam point. Ice point, it is a mixture of ice and water that is in equilibrium with air saturated with vapor at 1 atmospheric pressure. Steam point is a point at which the mixture of liquid, water and water vapor in equilibrium at 1 atmospheric pressure. Celsius scale is a scale measuring unit in SI unit, Fahrenheit in English units. Thermodynamic scales, a thermodynamic scale that is independent of the properties of any substance. So these are the comparison of various temperature scales. The reference temperature in the original Kelvin scale was the ice point. The reference point was changed to much more precisely reproducible point, that is triple point of water. The triple point is defined as state at which all the three phases of water coexist in equilibrium, which is assigned the value of 273.16 Kelvin. This is the relation between the different temperature scales. These are some of the self-assessment questions. Thank you.